Good afternoon, my student. It is time for chemistry lesson. My student, I want to welcome you, and today we are going to discuss about chemistry paper 3. Question 3. This is a practical question in this practical lesson, and therefore my student, I want to tell you what we are going to discuss here, but in 1 minute I can see my students are wondering, why is it that I've carried a whistle in the lesson? So my student, the whistle is just to alert you. I know most of you have the tendency of sleeping, dozing when I'm teaching. So this one is just there to awake you, to ensure that you concentrate. Is it okay, my student? And also, in my hands, I also have a straw. This one, I'll be doing this one. At least 4 to those who don't concentrate. Is it okay, my student? And also, I have my pointer, a black pointer. So I'll be using this one to demonstrate or to point on specific points when I'm teaching. Is it okay, my student? My student, without wasting time, let me now introduce the concept. So I want to talk about chemistry paper 3, as I've said, but specifically question 3. Is it okay, my student? Is it okay? Then, what am I going to talk about? I'm going to talk about qualitative analysis. What is qualitative analysis? My student, qualitative analysis is the identification of ions present in a sample or in a chemical substance. And ions are of 2 types that I'll talk about: cations and anions. Anions are negatively charged ions, while cations are positively charged ions. Is it okay, my student? But in this lesson, I'll talk about identification of cations. Then we ask ourselves this question, my student: what are cations? Cations are positively charged ions. Positively charged ions. Is it okay, my student? So, before I continue with this one, my student, before me, I have various chemicals here in form of solutions which we are going to use. Is it okay, my student? So I will take you through so that you familiarize yourself, my student, with these chemicals, so that when we start, you know what I'm talking about. So will you allow me start from my right here, so that we move along and cross-check and see which chemicals are present. So let me start from my right here. Is it okay, my student? So this is a solution containing zinc ions. It is labeled, just check on the labels: solution containing zinc ion, solution containing aluminium ions, solution containing lead ions. This is a solution containing barium ions, a solution containing magnesium ions. You can check. Solution containing calcium ion, solution containing sodium ion, solution containing lithium ions, solution containing potassium ions. Is it okay? Then another solution here containing iron 2 ions, another solution containing iron 3 ions, Then another solution containing copper 2 ions. And you know very well the color of copper 2 ions solution is blue. Is it okay, my student? Thank you. Then finally I have also these two solutions. Read there and see. This is sodium hydroxide solution. Is it okay? Then this one is aqueous ammonia or ammonia solution. Is it okay, my student? And when you look at these solutions, unlike the other solutions, I have placed there droppers. And these two solutions, my student, are very important in this lesson. They play a very important role. Why? Because I'm going to use these solutions interchangeably like this. And for you as a student, you will understand that these two solutions will enable you to identify various ions that by differentiating them, to differentiate. You can start with sodium hydroxide, you identify some ions, but now to distinguish them further, you apply this one, aqueous ammonia solution or ammonia solution. Is it okay, my student? Thank you. So my student, let us go back now to a serious business. My student, look, my student, I'm going to use sodium hydroxide solution, mostly then also ammonia solution. You can see their chemical symbols there. Is it okay? Then, yes, Anthony, what is it? You don't have any question? It's okay, concentrate. Good. So, whenever we use sodium hydroxide solution, my student, we have said that it has a dropper. So this means this solution is normally used dropwise. We normally start with few drops. Let's say 1, 2, 3, or 4. Those are few drops. Then we now add in excess. Is it okay? So we use a drop. Is it okay? Remember to use a dropper. Similar to ammonia solution. Is it okay? So let us see a case where we are now using sodium hydroxide solution to identify the ions. Very good. So they say add sodium hydroxide solution dropwise to the test tube containing a solution with various cations. So we normally have a table for observation and inferences. Is it okay? So let us see a situation where you add this sodium hydroxide and you form white precipitate. So white precipitates soluble in excess to form a colorless solution. If that is the case, my student, then we suggest the presence of zinc ions, aluminium ions, and lead ions. And my student, for me, I normally summarize them this way as the Z, where Z stands for zinc ions, A stands for aluminium ion, then P stands for lead ion. Is it okay, my student? But don't make a mistake of writing this one in the inference. This is just there to make you memorize or understand. Is it okay? But here in the inference, you just write zinc ion, aluminium ion, and lead ion present. Is it okay? Then a case where you form a white precipitate insoluble in excess of this sodium hydroxide. White precipitate insoluble in excess of sodium hydroxide. Then we suggest the presence of these three ions: barium ions, magnesium ions, and calcium ions. Is it okay? And I normally summarize this one this way, my student, as BMC, where B stands for barium ion, M stands for magnesium ion, C stands for calcium ion. Is it okay? Good. Then, in case where we have no white precipitate formed, my student, no white precipitate formed, we suggest the presence of these three ions: sodium, lithium, and potassium ion present. We suggest. Is it okay? And I normally summarize them as N, L, K, N, L, K. Where N stands for sodium, L for lithium, K for potassium. Is it okay, my student? Is it okay? Thank you, my student. Also, if you form green precipitates insoluble in excess of sodium hydroxide solution, then, my student, this one you know. Any green precipitate is associated with what? The presence of what? Ion 2 ions. Is it okay? And my student, that one is obvious. There is no need for me to stress a lot on that. Then, in case, my student, you add some drops of sodium hydroxide to that solution and you form brown precipitates insoluble in excess, that one is associated with the presence of what? Ion 2, ion 3, please. Ion 3 ion present. Is it okay? But if there are green precipitates insoluble in excess, ion 2 ion present. Is it okay? Then lastly, if you form a blue precipitate insoluble in excess, then we say copper ions present. So blue precipitate is always blue precipitates insoluble in excess is always associated with copper 2 ions present. Is it okay, my student? So let me now, James, you are looking at a phone when I'm teaching. Please, James, let me forgive you. James, let me forgive you. My student, let us concentrate, isn't it? This is a very important section that I'm talking about, my student, and you need to get the concept. Please. So let us now carry out the experiment, my student, and see. I'll start from my right here to test for the presence of zinc ions. You just take about 2 ml. Then this is sodium hydroxide solution. So I take sodium hydroxide solution. Then I add 3 or 4 drops. That is 1, 2, 3, 4. My student, check. Are you seeing the presence of white precipitates? Yeah. You can see them. You can see them even when I shake on the sides. Is it okay? That is when there are a few drops. Let me add in excess and see. Just check, my student. And my student, there is one thing that you must be aware. Most of our students are impatient, very impatient when it comes to performing these practicals. This one requires your patience, my student. Is it okay? Be patient. Just watch what is happening there. What has happened? I want one of you, my student, to tell me what has happened. Yes, Marion? Yes? Miracles? No, I'm not performing miracles here, my student. Yeah, very good. That's the answer now I wanted. The white precipitate dissolves in excess to form a clear solution or a colorless solution, isn't it? And that is what we have written here, my student. Here. White precipitate soluble in excess to form a colorless solution. That is for zinc. Is it okay? Allow me move on to the next because of time. This is a solution containing which ion? Aluminium. Is it okay? Let me see. You take very little, about 2 ml. About 2 ml. 2 mils if you like. So you add 2 or 3. That's 1, 2, 3. Are you seeing the white precipitates? White precipitates are formed, isn't it? So you continue with the excess of sodium hydroxide solution. Let us see. What has happened? White precipitate dissolves to form a clear solution or a colorless solution. Are you seeing that? We are done, my student. We move on. Another solution is lead, a solution containing lead ions. Let me show you lead ions. Is it okay? I just take about 2 ml, then some few drops of sodium hydroxide. 1, 2, 3. What has happened? White precipitate formed, isn't it? Let us try excess and see. Let us try in excess and see. Let us try in excess and see. My student, patience pays. What has happened? I'm not performing miracle, you know that. A clear or a colorless solution is formed. White precipitate dissolves in excess, isn't it? This is just to make you concentrate. Is it okay, my student? Thank you. So, we have seen, my student, that zinc, aluminium, and lead white precipitates in excess of sodium hydroxide solution, they dissolve to form a colorless solution. You have seen that, isn't it? So in an exam, you will be also doing the same. Is it okay? Let us move to this one. White precipitates insoluble in excess. Barium, magnesium, calcium, ion present. BMC. Is it okay? Let us see. You can watch barium versus sodium hydroxide solution, dropwise. The word is dropwise. Is it okay? You can watch this barium. So let me start with few drops, then excess. Those are a few drops. If you are not very keen, you may not observe this one, but there are some precipitates. Let me continue adding. Are you seeing some precipitates? Precipitates are you seeing now? You can see them, but yeah, you can see them. They are not, the concentration is not that too high, but you can at least see them. Are you seeing them? Let me continue adding in excess and see if they dissolve. Let me continue adding in excess and see if it can dissolve. It's now almost half. Even it is past half. It is now past half. It is almost full. But my student, there is no change. White precipitate does not dissolve. Are you seeing that? White precipitate of barium does not dissolve in excess sodium hydroxide solution. Is it okay? We have agreed on that. Yes, Anne. Are you seeing? Very good. I like the way you are very attentive. I like that, my student. Keep it up. Then you also perform that one with magnesium ion. Is it okay? Let me also test that one for magnesium. These are magnesium ions, solution containing magnesium ion. Few drops of sodium hydroxide. 1, 2, 3. Are you seeing the white precipitates? Is it okay? Good. Let me now add in excess and see if there is any change will take place. And my student, every time you must shake. Be patient and shake thoroughly. Shaking. It's all about shaking. Let me see. Let me continue adding. We want to see if the precipitates will dissolve or not. My student, even if you continue adding continuously, this one, the precipitates will not dissolve. Are you seeing that? Thank you. Then another one is calcium, a solution containing calcium ion. Is it visible? So let me take, and always remember to use a dry, clean test tube. What have I said? A dry, clean test tube. Is it okay, my student? Oh yes, let us go. And about 2 ml, or about 2 milliliters. So a few drops, 1, 2, 3, calcium ions. What are you seeing? White precipitate, isn't it? Let us add in excess and see if the precipitate dissolves in excess sodium hydroxide. Let us continue adding. You see the patience. Be patient, my student. Even me, I'm patient. You can see. Even me, I'm patient. Imagine, almost now 10 minutes, but I'm still patient on this one. Almost 10 minutes, but I'm still patient on this one. Is it okay? Let us continue adding and see if there will be any change. No observation. White precipitate does not dissolve in excess. Is it okay? Thank you. So my student, I'm done with that. White precipitate dissolved in excess, barium, magnesium, calcium present, BMC. You have seen that, isn't it? Let us see now ask question where my student, if any question is there, you ask. You ask my student. Oh, let me stretch a bit. Oh, I'm very tired, but let me continue. Is it okay? Very good, my student. So I want now to consider now this one. No white precipitate forms. We suggest the presence of sodium, lithium, potassium, ion present. NLK. Is it okay? So you can check here and see, my student. I have my sodium solution here. Is it okay? Let me now check. Let me do it in a proper way. About 2 ml. And always check the initial color. It's colorless solution. Is it okay? Let me add few drops of sodium hydroxide in a solution of sodium ions and see. 1, 2, 3. Is there any change? No change. No formation of any precipitate. No white precipitate formed. Now I've added in excess. Even if I continue adding and even take the whole of this one and pour here, you will not see any change. Is it okay? Is it okay? So no white precipitate formed. Let me also confirm with the lithium. This lithium, a solution containing lithium ions. About 2 ml. About 2 ml. This is how you hold this. Let me add continuously. Continuously. Even I've put the excess. But are you seeing any change? Let me continue adding drop by drop. Drop by drop. And I continue adding. Is there any change? My student, even if you continue adding this one, now, today, tomorrow, the following day, the following week, the following month, next year, 10 years to come, 100 years to come, no white precipitate will be formed. Is it okay? Thank you. Let us move on to another solution containing potassium ions. Is it okay? These are potassium ion. Another clean, dry test tube. Then I add few drops. Is there any change? The solution remain colorless, clear solution. Now in excess, almost 20 drops at once. Is there any change? Nothing. So it means if no white precipitate is formed, we suggest the presence of the 3 NLK. Is it okay, my student? Stella, are you getting it? Very good. I like that. I like the way my students are concentrating. Keep it up. Let me now talk about if you form green precipitate in soluble in excess, we suggest the presence of iron 2 ion, isn't it? My student, this is a solution containing iron 2 ions. This is a clean, dry test tube. About 2 ml. Few drops, then excess of sodium hydroxide solution. 1, 2, 3. What has happened? Which color is this? Green, isn't it? We have formed a green precipitate. Then let us see if it's solved in excess. And every addition you shake. Every addition you do what? You shake thoroughly, like that. Every addition you shake thoroughly. Every addition you shake thoroughly. My student, this one, there is no any sign of, it's almost full, but you see no any sign of what? Dissolution. It cannot dissolve. Is it okay? Ion to ion present. Then we have ion 3 ion, using the labeling, and 3 ion. Another clean dry test tube, about 2 ml. About 2 ml. Very good. Initially the solution is clear, isn't it? As usual. Let me add a few drops. 1, 2, 3. Which color is this? Brown precipitate, isn't it? The precipitates, you can see them. Brown precipitates formed. Let me add in excess and see what happens to it. In fact, the intensity of the brown color increases, and the precipitates are now very thick, very thick. Are you seeing that? The precipitates are now very thick. Let me now continue adding in excess and see if it will dissolve. Let me now continue adding in excess and see if it will dissolve. No dissolution, isn't it? Is it okay, my student? Jennifer, is it okay? I like it. Then Amos also concentrate. Good. Are you seeing that? Make sure. You know, I'm doing it here, but in an exam, my student will be alone, and a police officer watching over you like this. Is it okay? So here it is a joke, but during that exam time is when you will know. Yeah, I'm not performing miracle as the other one said. This is serious business, isn't it? Good. Then the last one here is so before you go there, brown precipitate is always in excess, ion 3 ion. Is it okay? Then if you get blue precipitates insoluble in excess, we suggest the presence of which ions? Copper ions, isn't it? What is the color of a solution containing copper ion? Blue. Very good, I like it, I heard it, but I don't like Cora's answers. I don't like Cora's answers. Another clean dry test tube, about 2 ml of this solution of copper 2 ions. Okay. Let us go. My student, let us go. Few drops in 3. 1, 2, 3. What do you see? What do you see there? Blue precipitate, isn't it? A blue precipitate. See, blue precipitate. You can see when they splash even to the sides, you can see them, isn't it? Blue precipitate form. Let me see in excess if there will be any change. Let me see if in excess there will be any change. Let me see if there will be any change in excess. Let me see if it will be any change in excess. Let me see if it will be any change in excess. This is just to make you, my student, be alert. Are you seeing the blue precipitates? Yeah, watch. I like this. I'm very happy now. I'm now very happy. Very happy with this one. I'm now very happy. Are you seeing, my student, the blue precipitates? And even if I continue adding, the blue precipitate does not dissolve. Is it okay? Then my student will say that blue precipitate insoluble in excess, we suggest the presence of copper 2 ions present. Is it okay, my student? Is it okay, my student? My student, I want to tell you something about what we have discussed today. When it comes to identification of these cations, for example, I want to talk about the ZA. Is it okay? Let me talk something about the ZA. Just watch here on the board. The ZA. That is Z for zinc, F for aluminium, B for lead. This one. Where white precipitate soluble in excess to form colorless solution. That's when we add sodium hydroxide solution dropwise. You have seen that, isn't it? So how do you differentiate now between zinc, and the two, aluminium and lead. We use aqueous ammonia, this solution. Is it okay, my student? Is it okay? This one aqueous ammonia. So we normally use ammonia solution. Ammonia solution. We use ammonia solution. So for the case of zinc ions, they form white precipitate which dissolves in excess ammonia. But aluminium and lead ions, their precipitates, my student, do not dissolve in excess ammonia. Am I talking? Let me show you. I cannot just say by saying. Let us do it. Where is my zinc ion? My zinc ions. They are here. These are zinc ions, my student. The solution initially is clear. So in this case, I'm using aqueous ammonia to bring the difference between the three. Here we use sodium hydroxide. But now if we use ammonia, let us see what happens to the zinc ions. 1 few drops, 2, 3. Are you seeing the white precipitate? And for zinc, the precipitate are always like, they look like oil, like fats. Are you getting it? So the white precipitate forms with a few drops of ammonia solution. Let me now see a situation where my student, I add now excess. Excess means very many, numerous, uncountable drops. Is it okay? Let us see. And my student, patience. I said be patient. When you are doing these things, it requires your time, your patience. Why are you hurrying? Where do you want to go, my student? Just watch very carefully. Let me add the last drop now. The last drop. The last drop now. And I see this one requires your patience. My student, you can now see the white precipitate has dissolved to form a colorless solution. Is it okay? Thank you. My student, also, if you use aluminium and lead, I'm forgetting my pointer. If you use aluminium and lead, the white precipitate will not dissolve. Let me show you as I wind up this lesson. Where is lead? Where is my lead? Let me start with the lead and then you see. This is lead. Then ammonia. Few drops. 1, 2, 3. Do you see the white precipitates? Do you see them? Let me see in excess what happens. In excess, you put there as many drops as possible. Uncountable, very many, numerous, millions. My students have done it for even more than 5 minutes, but no white precipitate dissolving. Are you seeing that? My student, this one also applies to aluminium the same. Is it okay? So as I finish, my student, well, let us see now how to differentiate what happens to copper in ammonia solution. We have seen that copper, it forms a blue precipitate which is insoluble in excess of sodium hydroxide, isn't it? But let us now see a situation whereby, my student, we now use a solution containing copper 2 ions. Then we add there ammonia solution, drop-wise, few drops, then in excess. What happens to it? This is where students normally mess up. Is it okay, my student? No, is it okay? But you are a good student. Let us go and see. Where is copper? My copper is on my left. So I confirm myself. I like that And you see, labeling of chemicals is very important. Why? This one is to avoid what? Confusion. Because if I don't label this, then I'll confuse. Is it okay? And confusion brings about poor results. Poor results, failure of exam. Is it okay? Is it okay, my student? Okay, let me take about 2 ml of copper 2 solution. So watch, I'm using ammonia. Initially, look at the solution is very clear. So you will notice the difference when I'll be adding in ammonia solution. Let me put there 3 drops and ensure you don't contaminate the solutions around. Is it okay? Thank you. 1, 2, 3. Then you shake. What has formed? You can see from this distance to here, you can see the color. These are precipitate. The precipitate is blue, isn't it? A blue precipitate, isn't it? So this blue precipitate, let me now continue adding excess. Look at the color, look at the initial color of the precipitate, and look at what is going to happen to this solution at the end when I add excess ammonia solution. Let us go. Let us go. Look at what's happening to the color. Look at what's happening to the color. Look at what's happening to the color. My student. Oh, what has happened? Hey, John, tell us, what has happened? Yes? Very powerful. The blue precipitate dissolves to form a deep blue solution. A blue precipitate dissolves to form a deep blue solution. I like it. Let us appreciate him. 1, 2, 3. I like it, my student. I like that. Look. Yeah, what John has said is very true. Look. Deep blue solution. The precipitate have dissolved. You cannot see any precipitate anymore. Just a clear blue solution. Thank you very much. So my student, in summary, zinc ions and copper ions in ammonia solution, they form precipitates. But when you add excess of ammonia, they dissolve. For the case of zinc ions, the white precipitate dissolves to form a colorless solution the way you have seen here, isn't it? To form a colorless solution for zinc precipitate. Then for the case of copper precipitate, which is blue, it dissolves to form a deep blue solution. Is it okay? My student, is very important. That is very important. So my student, in the next lesson I'll differentiate between B and C using ammonia, especially how to differentiate between magnesium and calcium ion in the next lesson. Is it okay? And my student, before I conclude, I want to summarize in a simple way. So always, when you identify cations, ensure that you know the solutions that are used. Is it okay? These two solutions are very important. Ammonia, we talk of aqueous ammonia and aqueous sodium hydroxide solution. So they are very important. Is it okay, my student? If there is any question, this is the time. But my student, the reason why I've taken my time to take you through this is because most students takes chemistry to be a very difficult subject. But I want to refuse that one. I want to say no. Chemistry is the easiest science. Is it okay? Because in our lives, it's all about chemistry. Is it okay? Chemistry is everywhere. The medication we take, those drugs, preparation require the knowledge of chemistry. Is it okay? Even those foodstuffs that we use at home, sugar, salts, apply the knowledge of chemistry. So chemistry is everywhere. Is it okay, my student? Let nobody cheat you that chemistry is difficult. Chemistry is very simple. My student, as I finish, Maybe some of you are wondering, I have my new student here. I can see very many new students around. My student, my name, I'm called Mr. KW. That is my name. I'm calling Mr. KW, a teacher of chemistry. Thank you. May God bless you so much.